National Electrical Code, or NEC, mandates disconnect means for readily accessible disconnection of service conductors at their point of entry from a building or structure when such a disconnect is required. The disconnect must be installed in a readily accessible location outside the building or structure, grouped and identified appropriately. Furthermore, it needs to be rated for the ampacity of the service conductors. The minimum voltage that typically necessitates a disconnect installation is 50 volts. This requirement can be found within NEC Article 430.102, which covers disconnecting means. NEC Article 430.102 specifically addresses disconnects for motor circuits, but the principle extends to general service disconnects based on voltage and other factors. Considering service voltage, there are different requirements for services over 600 volts, nominal, and services rated not over 600 volts, nominal. For services over 600 volts, nominal, several conditions apply. Firstly, where the service conductors enter through a raceway or enclosure, a disconnect is required. Secondly, where the service conductors are installed as open conductors or enter the building or structure above ground, a disconnect is also necessary. In both scenarios, the disconnect facilitates safe and accessible means of energizing the service conductors. The NEC further clarifies requirements based on how service conductors enter the building. For services rated not over 600 volts, nominal, there are also specific conditions. Firstly, where the service conductors enter service equipment enclosures through raceways or cables, a disconnect is required. Secondly, where service equipment enclosures are provided with doors or removable covers that afford access to substantially all of the enclosure interior, a disconnect is also necessary. These requirements ensure that personnel can safely isolate the electrical supply before working on the equipment. It is crucial to consult the latest edition of the NEC for the most up-to-date and precise requirements, as codes can be revised. The NEC provides detailed guidelines on disconnect sizing, location, and other installation requirements. Understanding the specific requirements outlined in Article 430.102 and related sections is essential for ensuring electrical safety and compliance. Always refer to the actual codebook for complete and accurate information. The installation of disconnects serves several critical purposes. Firstly, it provides a readily accessible means to energize electrical circuits or equipment for maintenance, repair, or in emergency situations. Secondly, it enhances safety by allowing workers to isolate electrical sources, reducing the risk of electric shock or arc flash incidents. Thirdly, it facilitates compliance with regulatory requirements and industry standards, ensuring that electrical installations meet minimum safety and performance criteria. Disconnects can be broadly categorized into two main types: fused and non-fused. Fused disconnects incorporate fuses that provide overcurrent protection, interrupting the circuit in the event of a fault or overload. Non-fused disconnects, on the other hand, only provide a means of disconnecting the circuit and do not offer overcurrent protection. The choice between fused and non-fused disconnects depends on the specific application and the need for overcurrent protection. When selecting a disconnect, several factors should be considered. Firstly, the voltage and current rating of the disconnect must be appropriate for the circuit it is intended to protect. Secondly, the disconnect must be suitable for the environmental conditions in which it will be installed, such as temperature, humidity, and exposure to corrosive substances. Thirdly, the disconnect must comply with all applicable codes and standards, such as the NEC and underwriters' laboratories, or all. The installation of disconnects must be performed by qualified personnel in accordance with all applicable codes and standards. Proper installation ensures that the disconnect functions correctly and provides the intended level of safety and protection. Regular inspection and maintenance of disconnects are essential to ensure their continued reliability and performance. Inspections should include checking for signs of damage, corrosion, or overheating. Maintenance should include cleaning and lubricating moving parts and tightening connections. Any damaged or malfunctioning disconnect should be replaced immediately. In addition to the general requirements outlined in NEC, there may be specific requirements for disconnects in certain applications, such as motor circuits, HVAC systems, and renewable energy systems. These specific requirements are typically found in the articles of the NEC that address these applications. For example, Article 430 of the NEC provides detailed requirements for disconnects in motor circuits, including the sizing and location of the disconnect. Article 440 of the NEC provides requirements for disconnects in HVAC systems, including the need for a disconnect that is readily accessible to the air conditioning or refrigeration equipment. Article 690 of the NEC provides requirements for disconnects in solar photovoltaic, or PV, systems, including the need for a disconnect that is readily accessible to the PV array. Understanding these specific requirements is essential for ensuring the safety and compliance of electrical installations in these applications. The NEC also addresses the use of different types of disconnecting means, such as circuit breakers and switches. Circuit breakers are automatic devices that interrupt a circuit in the event of an overcurrent or short circuit. Switches are manually operated devices that disconnect a circuit. The choice between circuit breakers and switches depends on the specific application and the need for automatic overcurrent protection. In some cases, both a circuit breaker and a switch may be required. For example, a motor circuit may require a circuit breaker for overcurrent protection and a switch for disconnecting the motor for maintenance. The NEC provides detailed requirements for the selection and installation of both circuit breakers and switches. The NEC also addresses the use of ground fault circuit interrupters, or GFCIs. GFCIs are devices that detect ground faults and interrupt the circuit to prevent electric shock. GFCIs are required in certain locations where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor areas. The NEC provides detailed requirements for the installation of GFCIs. The NEC also addresses the use of arc fault circuit interrupters, or ASIs. ASIs are devices that detect arc faults and interrupt the circuit to prevent fires. ASIs are required in certain locations where there is a high risk of fire, such as bedrooms and living rooms. The NEC provides detailed requirements for the installation of ASIs. Understanding the requirements for disconnects, circuit breakers, switches, GFCIs, and ASIs is essential for ensuring the safety and compliance of electrical installations. Always consult the latest edition of the NEC for the most up-to-date and precise requirements. Remember that electrical codes and standards are constantly evolving to address new technologies and emerging safety concerns. Staying informed about these changes is essential for electrical professionals and anyone involved in electrical work. Continuously updating knowledge through training, continuing education, and active participation in industry events can ensure that electrical installations are safe, efficient, and compliant. Disconnects play a vital role in electrical safety, providing a means to quickly and safely de-energize circuits and equipment. This is particularly important in emergency situations such as electrical fires or equipment malfunctions. Properly installed and maintained disconnects can help prevent injuries and property damage. Furthermore, disconnects facilitate routine maintenance and repairs by allowing workers to isolate electrical sources. This reduces the risk of electric shock and ensures a safer working environment. In addition to safety, disconnects also contribute to the reliability and efficiency of electrical systems. By providing a means to isolate circuits and equipment, disconnects can help prevent downtime and minimize disruptions. This is particularly important in critical applications such as hospitals, data centers, and manufacturing facilities. In conclusion, the NEC requirements for disconnects are essential for ensuring electrical safety, compliance, and reliability. Understanding these requirements and adhering to best practices for installation and maintenance are crucial for electrical professionals and anyone involved in electrical work. Always consult the latest edition of the NEC for the most up-to-date and precise information, and seek guidance from qualified electrical professionals when needed. The effective use of disconnects contributes to a safer and more efficient electrical infrastructure. Remember, electricity is a powerful force that must be handled with respect and caution. Following the NEC guidelines for disconnects and other electrical safety measures is essential for protecting lives and property. The goal is to ensure that electrical systems are designed, installed, and maintained in a manner that minimizes risks and maximizes benefits. Therefore, it is essential to use qualified professionals. They can assure this is done right. They are trained and licensed to do this work. When reading the NEC, keep in mind that each article builds upon the previous articles. For example, the general rules in Article 100 may affect specific articles. The NEC also includes informational annexes that provide additional guidance and examples. These annexes are not part of the enforceable code but can be helpful in understanding the intent of the code. It is also important to note that the NEC is not a design manual. It provides minimum requirements for safety, but it does not provide detailed design guidance. Electrical engineers and designers must use their professional judgment to ensure that electrical systems are properly designed and installed. The NEC is a living document that is constantly evolving to address new technologies and emerging safety concerns. The NEC is updated every 3 years through a consensus-based process that involves input from a wide range of stakeholders, including electrical professionals, manufacturers, and regulatory agencies. Staying informed about these changes is essential for electrical professionals and anyone involved in electrical work. Regularly reviewing the latest edition of the NEC and participating in industry events can help ensure that electrical installations are safe, efficient, and compliant. Always consult with the authority having jurisdiction, or OJ, to determine the specific requirements for electrical installations in a particular area. The AHJ may have local amendments or interpretations of the NEC that must be followed. The AHJ is typically a local government agency or building department. Working closely with the AHJ can help ensure that electrical installations meet all applicable requirements and are safe and compliant. Proper grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to return to the source, which helps to trip the overcurrent protection device and prevent electric shock. Bonding connects all metal parts of an electrical system together to create a lower impedance path for fault current. The NEC provides detailed requirements for grounding and bonding. Understanding these requirements and following best practices for grounding and bonding are crucial for ensuring electrical safety. Surge protection devices, or SPDs, protect electrical equipment from voltage surges caused by lightning strikes or other events. SPD diverts surge current away from sensitive equipment, preventing damage. The NEC requires SPD in certain applications, such as critical facilities and sensitive electronic equipment. Understanding the requirements for SPD and installing them properly can help protect electrical equipment from damage and ensure the reliability of electrical systems. Electrical safety is a shared responsibility. Everyone involved in electrical work, from electricians and engineers to homeowners and business owners, has a role to play in ensuring that electrical systems are safe and compliant. By following the NEC guidelines, staying informed about electrical safety practices, and seeking guidance from qualified professionals, everyone can help prevent electrical accidents and protect lives and property. The information in this narration is intended for general educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrical professional before undertaking any electrical work. Ignoring safety precautions and unqualified work can lead to serious injury or death. It is also important to understand the terminology used in the NEC. The NEC uses specific terms to define different types of electrical equipment and installations. Understanding these terms is essential for interpreting the code correctly. The NEC also includes definitions of common electrical terms. For example, the NEC defines the term ground as a conducting connection, whether intentional or accidental, between an electrical circuit or equipment and the earth or some conducting body that serves in place of the earth. Understanding these definitions is essential for interpreting the code correctly. The NEC also uses abbreviations and acronyms. For example, the NEC uses the abbreviation NEC to refer to the National Electrical Code. The NEC also uses the acronym GFCI to refer to a ground fault circuit interrupter. Understanding these abbreviations and acronyms is essential for interpreting the code correctly. The NEC also uses tables and figures to provide additional information. For example, the NEC includes tables that list the ampacity of different types of conductors. The NEC also includes figures that illustrate different types of electrical installations. Understanding these tables and figures is essential for interpreting the code correctly. The NEC also includes examples to illustrate how to apply the code. These examples can be helpful in understanding the intent of the code and in applying the code to specific situations. The NEC also includes references to other standards. For example, the NEC references standards published by Underwriters Laboratories, or UL, and the Institute of Electrical and Electronics Engineers, or IEE. These other standards provide additional information and requirements for electrical equipment and installations. Understanding these references is essential for interpreting the code correctly. The NEC is a complex and comprehensive document. Interpreting the NEC correctly requires a thorough understanding of electrical principles and practices. It also requires a careful reading of the code and a consideration of all applicable factors. It is the electrical inspector's job to interpret the code and to ensure that electrical installations comply with the code. The electrical inspector is typically a local government employee who is trained and certified to inspect electrical installations. The electrical inspector has the authority to approve or reject electrical installations. Working closely with the electrical inspector can help ensure that electrical installations meet all applicable requirements and are safe and compliant. The NEC is not intended to be a substitute for engineering judgment. Electrical engineers and designers must use their professional judgment to ensure that electrical systems are properly designed and installed. The NEC provides minimum requirements for safety, but it does not provide detailed design guidance. Electrical engineers and designers must consider all applicable factors, including the specific application, the environmental conditions, and the available resources, to ensure that electrical systems are safe, efficient, and reliable. The NEC is a valuable resource for electrical professionals and anyone involved in electrical work. By following the NEC guidelines, staying informed about electrical safety practices, and seeking guidance from qualified professionals, everyone can help prevent electrical accidents and protect lives and property. This narration covered several important aspects of the National Electrical Code, or NEC, regarding disconnects and electrical safety. It emphasized the importance of understanding the minimum voltage requirement for disconnect installation, which is generally 50 volts. It also covered the NEC Article 430.102, which outlines the requirements for disconnecting means for services over and under 600 volts, nominal. This includes the conditions under which disconnects are required, such as where service conductors enter through raceways or enclosures, or where service equipment enclosures are provided with doors or removable covers. Furthermore, the narration discussed the different types of disconnects, including fused and non-fused disconnects, and the factors to consider when selecting a disconnect, such as voltage and current rating, environmental conditions, and compliance with codes and standards. It also emphasized the importance of proper installation and maintenance of disconnects, including regular inspections for damage, corrosion, or overheating, and the need for qualified personnel to perform electrical work. The narration also touched upon specific requirements for disconnects in certain applications such as motor circuits, 8-track systems, and renewable energy systems, and the use of different types of disconnecting means such as circuit breakers and switches. Finally, it highlighted the importance of grounding and bonding, surge protection devices, and ground fault circuit interrupters, and the shared responsibility for electrical safety among electrical professionals, homeowners, and business owners. The narration stressed the importance of consulting the latest edition of the NEC for the most up-to-date and precise requirements and seeking guidance from qualified electrical professionals when needed.